Hello, 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 and welcome back, everybody. We've made it. We're at the last question, question number 25 on the 2004 Grade 7 Gauss competition. Okay? So, yeah, I don't really have anything to say. Let's just get into it, okay? So, a grid with 10 rows and some number of columns, probably going to make us figure out what that is made up of unit squares as shown. The domino can be placed, or a domino can be placed horizontally or vertically to cover exactly 2 unit squares. Okay, just like if you placed a domino on a chessboard or checkers board. There are 2004 positions in which the domino could be placed. The number of columns in the grid is 105, 106, 107, 108, 109. Okay. So, the domino can be placed horizontally or vertically, cover exactly 2 units. So what I'm going to do is I'm just going to do a little bit of an investigation. I'm going to say, okay, so the domino can either be placed horizontally, so it's stuck in a row, or vertically, so it's stuck in a column. So let's take, we know the columns have sort of height 10 here. So let's just take a single column. We'll say the domino was placed in this column. And we'll say, okay, how many ways can we place the domino in this column? And the same sort of counting should probably work for the rows, because rows are just columns where everything's rotated. So let's see what that does. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we'll let our domino be a little red line. So our domino could go here, or it could go here. 3, 4, 5, 6, 7, 8, 9. So 9 ways to place domino in a column. Okay. So 9 ways to, so why did that work? Well, let's do a little more investigation and see. So what happens? Let's move on to rows. So there's 9 ways to place it once we've chosen a column. If I had a row just of 2 things, my domino could only be placed in one thing. So 2 squares, so a 2-square row, 1 way to place. What if we had 3? Well, my domino could go here, or it could go here. So 3 squares, 2 ways. So I'm beginning to see a pattern here. What if we had 4? My domino could go across, or across, or across. So 4 squares, 3 ways. So what's going on here? No matter how many squares we have, the number of ways we can place our domino seems to be 1 less. And so the way it works is for a column of, let's say, n squares, if it's a column, the domino has to be placed vertically, right? And once the top square, or the top half of the domino is placed, the position is fixed. And we can do say the same sort of thing with rows, but it'll be sort of the leftmost square of the domino, or leftmost half of the domino is fixed. So for a column, where can that top half of the domino go? Well, it can go in any of the squares except the last one, because if it went in the last one, since it's the top half, the domino would have to be sort of be hanging off the board. So there are n minus 1 places for the domino. Or at least for the top half. But once it's placed, that means n minus 1 places. For the domino. Okay? And the same sort of thing would happen, again, if you did it with a row. Okay, that's what we saw. When we had a row consisting just of 2 squares, there'd be only one way to place that domino. Okay? So I think with this piece of information, we're ready to stop looking at just columns and rows. And this sort of sprang along kind of quickly. All I was doing was trying to figure out how many ways to place a domino in one of the single 10 by 1 columns. But we've got quite a little theory here going here. So I think we're ready to sort of say, let x or something be the number of columns. Okay. And then I think we can probably, because we're starting to figure out a number of ways our domino can be placed in a column. So we'll say we've got, I'm not going to draw the full picture, but we're just going to sort of say, oh, this is 10, and we're going to keep going. We'll have x columns. We'll go all the way over to the end, and it'll also have 10, but we're not being super exact here. Okay, so it's their picture that they've got. Now, once we've chosen, so there are x columns, and each column has 10 in it. So there's, we know, 9 ways to place in a column. 9 ways we can place that domino in the column. So that gives us a total of 9x placements for the domino. Because we multiply. We choose our column, there's x of those, and each of those has 9. So 9 times x. 9x placements for the domino. Okay. And now we have 10 rows. And in each row, since there's going to be each 10 rows sort of x squares, times, or we'll use the dot times because we got an x in the question. Maybe I should have used n. So since there are x squares in the row, we know that there are x minus 1 ways to place the domino. Or rather, 10x minus 1. So we have 9x ways to place the domino if it's vertical, 10x minus 1 ways to place it if we're placing the domino horizontally. If we add all those up, we're told that it's 2004, right? Yep, 2004 positions in which the domino could be placed. So now I know 2004 is going to be the number of ways to place the domino vertically, plus the number of ways to place the domino horizontally. And I can expand one of these a little bit, 10x minus 10. I'm going to bring the 10 over to the other side, so 2014 is a 9x plus 10x, that's 19x. So x, the number of columns, the thing that we want to solve for, should just be 2014 over 19. I don't know if 2014 is divisible by 19. I hope so, but I'm going to grab my calculator. Okay, calculators are allowed. Why try long division when we can just enter in some buttons? I'm getting 106, so you know I didn't think 2014 would be a multiple of 19. Not a lot is, but evidently it was, and that sort of confirms to me that I probably went about this the right way. It seemed this went kind of quick. And it's, in which case, good. It seems like the question sort of flowed naturally to me. Maybe it didn't so much to you. But we have our answer here. 106 columns. And I do remember 106 was one of the answers. C? No, it's B. 106. So we have B, 106 columns. And that does it. We're done. We're done. Hooray! We finished the 2004 grade 7 Gauss. So thank you guys for watching. If you're looking for a bit of a challenge, I'll be doing the grade 8 level 2004 Gauss starting in the next playlist. But if you're looking for more grade 7 Gausses, of course, I've already done the 2003, and the 2004 will be the next one I get out. So thank you guys for watching, and I hope to see you in some other video at some other time, and keep on practicing your math contests. So long.